Hello, thank you for watching this video. I'm going to be covering variations, the subtopic direct variations. Understanding variation is simply understanding that you've got two things that have this relationship whereby the first one increases as the second one also increases, or the first one grows relatively to the second one also growing. So if we have A and A is directly proportional to B, then that is an example of direct variation. Let's use scenarios so we can easily understand this. Here in the first example, we see that if you receive $10 every 1 hour, well, that means that after 2 hours, you've got $20. After 3 hours, you've got $30. After 7 hours, you've got what? You've got $70. After 10 hours, you've got $100. So there's that relationship where we can see money increasing as time is increasing. And also, if we are just given randomly, let's say if you're given if you are told that by now you've got $80, you can easily infer that, well, 8 hours have passed because of that relationship that as the money is increasing, the time is increasing, and you can easily tell how much time has increased by the amount of money you have received, and vice versa. Let's take a look at another example here. We have if you grow 10 centimeters taller every 2 minutes, well, that means as time passes, with more time passing, you are growing taller and taller and taller. So after an hour, you're much more taller than you were before that hour it started. Because you can see that relationship again. Your height being able to grow as time is growing, or as time is increasing. And the last example we have, if 3 people are born each 5 days, or we can tell that the population of a country is going to grow as the days pass by. So there are gonna be 6 people after 10 days. There's going to be 9 people after 15 days. Now, as this is as a result of this relationship that we have seen, that if 3 people are born every 5 days, so people are increasing as days are passing. And also, what you have to notice within these examples that you're given is that this relationship has got this sort of factor whereby one number is being multiplied by a factor to get the other one. So, for example, if you're asked, would you like to receive $10 every 1 hour, or $10 every 2 hours, or would you like to receive $10 every 10 hours? Of course, you would go for the $10 every hour because that is how you get money much faster, because that relationship of $10 every hour is much steeper, or it's much faster than you getting to receive $10 every 10 hours. That'll be a slow rate of you receiving money. So that is what we are inspecting when we are understanding direct variations, because that factor, which is usually noted by the K, is what determines the relationship that comes out between X and Y, or A or and B, or D and S. Whatever things that you have, the two things that you have are determined by this K, the factor that is used to multiply one to get the other. Let's take a look at an example of this direct variation. Here we've got A and B, which have their relation. So when A is 20, B is 15, and we are told to find the law connecting A and B. So like we said, A is increasing as B is increasing, so they have that proportional, or that directly proportional relationship. So A is directly proportional to B, and we can denote that by saying A is equal to KB, because we get A by multiplying K with by multiplying B with a factor K. So since when A is 20, B is 15, we get to say 20 is equal to K 15, because this factor K multiplied 15 in order to get the 20. So now, in order to get this factor K, we just divide 20 by 15. So now we are left with K is equal to 15 over 20, and we get to actually see that our relationship K is 3/4. So that's how we got the K. And so find the law connecting A and B. The law is actually A is equal to 3/4 multiplied by B. So whenever you want to get any A, you get to multiply 3/4 by some B. So if you are given that B is 10, you just say 3/4 multiplied by 10, and then that's how you get the A that corresponds with that B. That is the relationship here. that has been established. So when we go to B and we are told to find A when B is equal to 2,5, well, it's simple. We just take our relationship that we just established here, or our law. So A is equal to 3 over 4 B. So A is equal to 3 over 4 multiplied by that 2,5. When B is 2,5, A is what? Is 1,875. Simple multiplication. So you can see how from these first two set of numbers that were given, we derived this relationship. And because we have this relationship derived, we can use it anytime from like after that. So now we can use it even in part C here, where we're told to find B when A is C. Well, when A is C, we get to multiply 6. Oh, sorry, not when A is C. When A is 6, when A is 6, we get to multiply that 6 by 4 over 3. So we are taking this 3 over 4, this side, we make it 4 over 3, multiplied by 6. And that's how we get our B. So our B was actually 8. And you can verify this by multiplying B by 3 over 4 to get 6. So now that we know our relationship here, which was derived in part A, we can use this at any time. So whenever you're given any A or any B, you can find the other. Let's take a look at example number 2. Here we've got given that y is directly proportional to x and y is 60 when x is 10. Well, we get to write that down here. Y is directly proportional to x, which means that y is equal to kx, because in order to get y, we would have multiplied x by this vector k. So we put our numbers here, 60 and 10, and then we get to find our k first. So dividing both sides by 10, we get k is equal to 6. And then to answer our question for part A, find the relationship between y and x, well, y is equal to 6x. That is the relationship that we are given in this question. And we're going to be using this relationship all the time. So now that we are told in B to find x, or to find y when x is equal to 1 and 2 over 5, well, it's simple. We just take our relationship that we found earlier, y is equal to 6x. We multiply 6 by 1 and 2 over 5 to get our y. So that gives us 8 and 2/5. So that's how we do our B. Now moving on to C, find x when y is equal to 84. Or simple, again, we start with our relationship that we established in A, that y is equal to 6x. And then we get to put the numbers that we have. So y is 84, and then we already have the 6. So now we need to find x. In order to find x, we divide both sides by 6. We actually see that x is equal to 84 divided by 6. X is equal to 14. That is our answer. In this question, we are told to copy and complete the table and then sketch the graph of x against y. Then later on get to comment that we get to comment whether that relationship is direct or otherwise. So in order to fill in this table, we have to notice the pattern that is happening here. So from 3 to 5, 2 was added. From 5 to 7, 2 was added. 7 to 9, 2 was added. So you can only assume that we add 2 to this number, or we add 2 to 9, and then we get this number, and this number plus 2, that gives us 13. So 9 plus 2 is 11, and indeed 11 plus 2, we get 13. So we can assume that the correct answer for this is 11. Let's take a look at filling at the bottom. So here we've got 4 blank, then 10. Well, from 10 to 13, that's 10 plus 3 gives us 13. 13 plus 3 gives us 16. So we can assume that 16 plus 3 is this answer, and then 4 plus 3 is this. Indeed, when we say 4 plus 3, we get 7, and 7 plus 3 gives us 10. So this part is actually 7. And then 16 plus 3 gives us 19. So we have filled out our table. And then in order to plot, we get to draw this graph. We get to draw the axis that we see. So 0 to 25, 0 to 25. Then we get to plot 3, 4, 5, 7 as shown in this graph. So sketch the graph of x against y. That's what we did when we plotted this. And then if you'd like, you can draw a straight line across these points. Yeah. And then comment whether this is a direct relationship or otherwise. Or as you can see, X values are increasing as Y values are increasing. So this is actually a direct relationship, because if you are told, let's say, if X is 1, what is 5, you come here to 1, and then you get to see Y is somewhere along here, so this gives you Y. Or if X is 5, then what is Y? You come here to 5, you go to this point, you see Y is somewhere, it has increased. Now if X is 10, what is Y? You come here along the X-axis, you get to go up to a graph, and you get to find the Y value. So you can see the X values are increasing as Y values are increasing, which gives you a direct relationship. So Y is directly proportional to X.